webinar, SAE Automotive EMC Testing for North America. Thank you for joining us. This webinar is being given by MET Laboratories. MET is a leader in the testing of electrical and electronic equipment for environmental hardiness, product safety, and electromagnetic compatibility. MET operates world-class labs in Baltimore, Maryland, Santa Clara and Union City, California, Austin, Texas, and also runs operations in China, Taiwan, Korea, and Italy. This webinar will run 30 to 45 minutes with an additional 15 minutes for questions and answers. Due to the number of registrants, all attendees will have their phones muted. If you have a question, please type it in the questions area of your GoToWebinar control panel. We will attempt to answer all questions at the end. If you are having technical difficulties, you can contact us the same way or call us at 330-418-9414, and we will try to resolve it quickly. Just a quick note on other upcoming events. On Thursday of this week, we will have a webinar on telecom interface testing, and in December, we're hosting a webinar on watt-hour meter testing and certification. Registration for these events are at www.metlabs.com. Today's webinar is being presented by Asad Bajwa. Asad is the Director of EMC Testing for MET. At this point, I will hand over the presentation to him.
Hello, everyone. Welcome to our webinar. Tasha, thank you very much for the introduction. Today we're going to talk about the SAE standards, and we'll go through doing a comparison how the SAE standards correlate with the requirements worldwide, specifically with the European automotive requirement. And time permitting, we will also try to explore some of the test methods as they are called out by automotive standards in North America, primarily the SAE standards. Here is a brief outline of my presentation. We'll start with the SAE standards, what their background, where they come in picture, their legality, the other legal requirements in North America. We do a comparison with E-mark and capital E-mark. We'll look at some of the test methods and explore some of the laboratory recognition programs and talk about some of the test methods. Okay. Before we jump into the specifics of the SAE standards and do a comparison between SAE and other international requirements for automotive testing, I believe it's important to briefly talk about what makes the automotive EMC testing so special that we have to talk about this separately, and we have to have separate standards different from the commercial products or military products which are used on a daily basis in our lives. For example, for a server-like product, there will be standards. North America will deal with that kind of product using some of the FCC rules, namely FCC Part 15, Subpart D. If that product goes to Europe, we'll be talking about ID category, where a standard like EN55022 and EN55024, among other, may be applicable, depending upon the specifics of the product. So again, the question comes, why would we treat an automotive product differently? Primary reason is that vehicles are not grounded the way any other electronic product which is installed in a house or a building or in a home would be grounded. The threat levels will be very, very different. All the product assemblies are mounted to a metallic structure. Which is being lifted by the wheels, which is rubberized for all the various good reasons. So the threat levels are very, very different. Another way to look at it is to look at the energy stored in the battery compared to the power source we will have to our homes and the buildings. Batteries, at times, if there's a short circuit, can provide for a short duration infinite amount of energy. So that adds another layer of the threat level, which makes the automotive testing very, very unique. if you look at from the electrostatic discharge perspective, again, the EST model, which we use for everyday product testing, for commercial and military product testing, is primarily based on a human body model, where there's a defined value of capacitor and resistor, whereas for automotive world, again, due to the different grounding techniques, due to the way the vehicle is suspended upon the, generally speaking, wheels, and for the most of the vehicles today we have, even today, the large structure of the body is metallic. So it will be a different, totally different ESD model compared to what is used in everyday commercial testing. So all those reasons, automotive testing becomes unique due to the different configuration, different grounding configuration, different threat level, different power source impedances, running of larger harnesses within the vehicle. All that make a huge difference when we talk about the EMI testing, EMC testing for the automotive world. I already mentioned some of the things which is summarized on the slide, that, for example, the components are packed very closely. Electronics are packed very closely. Many of the vehicles will have antennas for various applications, either for radio reception. Some vehicles may have Wi-Fi personality, or some of them may have cellular personality, where they can talk to a cell tower for various services they use, either for accident or for emergency services. So again, from that angle, the electronic assemblies within the vehicle are exposed to much larger field strengths compared to a commercial product in somebody's house. Another thing which we talked about, the harnesses. The harnesses compared to a commercial product could be fairly very long, running within the vehicle, and they become susceptible to either the field strength, or they can pick up the transients, or they can have induced fields emerging from various parts of the vehicle or from the outside world. So for all those reasons, EMC testing for automotive application is quite unique, and there are different set of standards to deal with the unique phenomena as far as the EMC is concerned for automotive products. Okay, so if we look at, if you try to categorize the automotive requirements for, say, for example, for North America, I can categorize in two ways. The legal requirements, and I can have a second category which is based on the vehicle manufacturers, or what we call customer-driven requirements. So by law, as we know, FCC governs the spectrum and the EMC requirement for all the digital products. However, for the products, for the electronic sub-assemblies which go into a vehicle and vehicles themselves, unless they have a transmitter personality, they are exempt from FCC rules. If you look at FCC Part 15, Subpart B, there is, I think, Rule 15.103, which talks about the exemption from the requirement for FCC Part 15, and there it specifically says the products which are meant exclusively for vehicular application, they are exempt from the FCC rule part. FCC has FCC under my apologies. NIST has designated the rulemaking for automotive products to ANSI, and ANSI eventually designated that rulemaking writing of the standards to Society of Automotive Engineers, which does a whole bunch of standards for not only for vehicles, for boats, for aircrafts, and many other products out there. If we do a comparison between the U.S. legal requirement and the legal requirements in Europe, the European requirements are governed by the Automotive Directive. Essentially, in other words, what it means is once a manufacturer would go through the Automotive Directive, they will be going for E-mark. Then there is a small distinction between capital E-mark and lowercase E-mark, and we'll talk about in next few slides. One point of clarity I would like to mention, even though the automotive assemblies, sub-assemblies are exempt from the FCC regulations, however, there are some state and other government organizations like Department of Transportation based requirements which each automotive manufacturer has to meet certain minimum requirements. So those requirements may still be out there in addition to whatever the SAE standards you may want to test your product to. I will briefly mention some of the requirements by the vehicle manufacturers. I have a separate slide to talk a little bit more specific about it, and we'll look at the details when we get to that slide. Okay. Requirements for vehicle and the components. As I mentioned, for Europe, the requirements are covered by automotive directive. And when a manufacturer go for automotive directive, their product, whether it's an electronic subassembly or the vehicle or other parts, they will qualify for lowercase E-mark. However, there is a parallel process where an automotive manufacturer can go for capital E-mark if they choose to qualify their electronic subassembly for vehicles under UN Regulation 10.4. .4 is the latest rev of the Regulation 10, which is written under the mandate of the United Nations, basically. So all the member nations who are part of this agreement under Regulation 10, once this product is approved by an approved organization within the member nations, then that product is considered to deemed to qualify to be sold or placed on market within the member nations who are part of the European Union mandate. Looking at North America, the primary requirements, as I mentioned, my apologies there, primarily the standard writing body for automotive standard is SAE, the Society of Automotive Engineers. However, each automotive manufacturer, for example, if we talk about the three larger automotive manufacturers like Chrysler, Ford, and GM, they have their own qualification program where they will have their own set of regulation which may be based on standards like CISPR 25, which may be based on and which may give reference to the standard like SAE standard, which is SAE J113 series or SAE J551 series of the standards. A couple of years ago, these three large automotive manufacturers came up with a laboratory recognition program in association with A2LA, which was called AEMCLRP. That program was out there for several years to help the test laboratories go through a qualification program. So once a lab becomes part of the program, the subcontractors or the manufacturers who are building the electronic subassemblies, they can qualify their products through these approved laboratories, and it will be considered that it meets the requirement of either Ford or Chrysler or GM. However, later this program was disbanded, and now each of these three manufacturers I mentioned, they have their own qualification program, and if labs choose to work with them, they will have to come up with coordinating with each of these manufacturers and go through the approval process separately. At this stage, I think it's appropriate to do a quick comparison. We talked already about E-mark. We briefly mentioned SAE requirements. So the process for E-mark is, whether it's a lowercase or uppercase, testing requirements are fairly very similar. You go through emission testing, which is narrowband and broadband radiated and conducted emission. There are transient conducted emission testing. Then there are radiated susceptibility testing if the vehicle is considered to have a safety-related function, so on and so forth. And end of the day, when all the testing is done, it's more like a type approval process. So depending upon whether you're going the automotive directive route or you are going to the UN Regulation 10 route, you will qualify for either a capital E or the lowercase e. And on the right-hand side of my slide, I have a couple of examples which would show how the E mark label will show up on your product. Next, I want to briefly share with you some of the international standards, namely ISO standards, CISPR 12, CISPR 25, some of the SAE standards. Just want to have a quick comparison and mention where they come in picture. For example, if you look at ISO 7637, which has various parts, and I have one more slide to talk a little bit more specific about there. Similarly, ISO 11451 has various parts. Similarly, 452 have several parts. And all of these standards come in play when you are talking about testing requirements for either E-mark, or you're talking about the UN Regulation 10, or even some of the automotive requirements for North America. They will be referencing to these ISO or international standards for test methodology, for limits, or so on and so forth. For example, 7637 talks about various transient immunity testing, which are commonly referenced as Pulse 1, Pulse 2, Pulse 3, so on and so forth, and it goes all the way up to the Pulse 5. Between each manufacturer, each automotive manufacturer, there might be a slight deviation from the definition of the pulse. There might be slight deviation in terms of the output impedance of the generator, or there might be slight deviation in terms of the rise time or fall time from one pulse to the other. However, for the large part, the requirements are fairly similar. Let's look at CISPR 25. Which is basically an IEC standard. It's an international standard again, and it's referenced very frequently by Regulation 10, by Automotive Directive, and by the three larger manufacturer requirements. And over the top of that, many of the SAE standards would refer to CISPR 25 for the specific test method. For example, there used to be a requirement several years ago, SAE J113-41, which would talk specifically about radiated emissions. Later, that requirement was pulled off, and the standard refers to CISPR 25 as a direct method, which has superseded the -41 requirement. And today, anybody who has to go for SAE testing would be referencing to the international standard CISPR 25 for narrowband and broadband emission testing. As I mentioned in the previous slide, 7637, which is basically talking about the power-related testing for conducted transients on the power lines. And there are three different parts. Section -1 covers the 12-volt systems. -2 cover 24-volt system, depending upon it's a commercial automotive vehicle or a truck. Then between these two, they talk about various waveforms or pulses, transient pulses, which are based on different phenomena. For example, the vehicle is running and there's a disconnection from the battery terminal, what sort of transient it would generate. So they will talk various scenarios which can lead to various high energy transient pulses, which when subjected to the electronic sub-assemblies or various electronic parts of the vehicle, the assessment would be to see if the vehicle can continue to operate safely in a manner it doesn't become a threat for the driver or passengers or anybody around where the vehicle is moving. OEM requirements, which is another big thing. We can talk about SAE requirements. We can talk about many other requirements. However, above and beyond, OEM would always have their own specific requirements. We can look at some of the key manufacturers, and I already mentioned some of them, like Ford, Chrysler, and GM, which are from North America. However, above and beyond that, if you look at BMW, we look at Volkswagen, we talk about Toyota, all of them have their own specific requirements. So if you are a manufacturer who is selling their electronic subassemblies or modules to one of these manufacturers, you will have to work with one of the labs who have been approved to perform testing to their specific needs, and then and only then your product will qualify to meet their minimum requirements, and they will consider working with you. Let's continue. Next, I want to briefly go over a little bit of history about SAE Society, which is Society of Automotive Engineers. Some of these things I briefly covered early on in my presentation, but I decided to put the slide there as a reference for everybody if they need more information. As the name states, SAE stands for Society of Automotive Engineers. It has more than 84,000 members. Primary function they have is they've been mandated by ANSI to write standard for automotive products, and that's their main function. So whether it's an automobile, it's a truck, it's a bus, it's off-highway equipment, aircraft, aerospace vehicles, so on and so forth, SAE is primarily responsible for writing those standards. I might be going slightly off the topic, but just to give you an example, the folks who are familiar with the avionics testing, there's a standard out, RTC DO160. So the section 22 of DO160 falls under the mandate of SAE Society, and they are primarily responsible for maintaining and updating the requirements as any changes come to that section, which is basically indirect lighting requirement for avionics products. So they have far-reaching requirements, and they cover a very broad spectrum of the automotive products, including aircrafts and automobiles, as far as their mandate goes. Okay. Next two slides, I want to just do a slight comparison and briefly talk about some of these requirements. There are two main standards out there, or I should say series of standards out there, namely SAE J551 and J113. J551 covers requirements for full vehicle testing, and J113 series cover the requirements for electronic subassemblies. So when we talk about automotive products testing, two things come in mind. Whether we are testing a module, which is the word in the automotive standard is used more frequently than module is electronic subassembly, or a full vehicle is being tested. So the way the requirements are laid out, one could choose to qualify each individual subassembly or module for a vehicle, or the other approach could be that a manufacturer could choose to have all modules plugged into a vehicle and do the full-fledged vehicle testing, and it will be considered at the end of the day all the modules which were present during the final testing, assuming the product was compliant, will be considered to meet the requirement. Those requirements are covered by J55 series, which will cover emissions, which will cover radiated susceptibility, which will cover ESD, which will cover bulk current injection, electrostatic discharge, magnetic immunity, so on and so forth. And I have listed the most commonly referenced parts, which go from 1 all the way to 17. And as my second last column indicates, all of these requirements are applicable to full vehicle testing. Similarly, J113, as I mentioned, covers electronic sub-assemblies. And if you see, the rule parts go from all the way from 1 to 42. And these requirements are for electronic sub-assemblies. And as I mentioned earlier, dash 41, J113 dash 41 has been now superseded by CISPR 25. However, I left it there as a reference to show how they come in picture in terms of their different tool parts. At this stage, I'm leading towards the end of my presentation. I think I want to cover one more standard, which is SAE J1455, the latest rev is of the year 2012. The reason I want to mention J1455 is that it's a very commonly requested standard if you have a generic module or a product and you don't have finalized who the end user may be. So this particular standard, which is primarily designed for heavy-duty trucks, will give you a very fair picture once your product been through this particular standard testing, if it would meet majority of the requirement out there from various manufacturers or various regulatory requirements once this product been through 1455 program. So let's look at this, how it will apply, what are the requirements. My apologies there. Let me try to finish this part first. So J1455 will cover radiated emission. It will cover radiated susceptibility. It will cover electrostatic discharge. It will cover some of the transient conducted emission and transient immunity testing. In addition to that, J1455 also have a major portion. Almost half of the requirements are the environmental requirements in terms of the vibration, humidity, temperature, shaking, and baking. So once your product goes through the compliance, not only it will be tested for electromagnetic environment, it will also be tested for environmental hardiness. Let's talk more about SAE J113 -1, and we can look at the series. It will be covering, as I mentioned earlier, voltage transient, and I had a slide which shows all the rule parts, all the sub parts of the J1113 series, which will cover the voltage transient immunity, which will cover audio and radio frequency susceptibility, conducted emissions, radiated emissions, which are primarily based on CISPR 25, which basically covers the narrowband and the broadband emissions, which are both radiated and conducted emissions. Frequently requested tests. For North America, the frequently requested tests are, even if you look at in the context of J1455, which is a very frequently requested requirement, oftentimes we get requested to perform, in terms of the automotive testing, narrowband, broadband emissions. We are requested to perform transient emissions, which are based on ISO 7637. We are requested to perform radiated susceptibility, which is based on 1145-2-1, I believe. And then we are asked to perform transient immunity testing, which is based on ISO 7637-1 or -2, depending upon whether it's a 12-volt system or whether the vehicle is based on 24-volt system. So these are some of the very commonly requested requirements. And once a product been through this sort of program, it helps ensure it gives a much higher peace of mind to the manufacturer when they go through the final compliance with one of the manufacturer. Their product will meet the specific requirements out there. Very quickly, I wouldn't want to spend too much time there. We are reaching toward the end of the presentation time. This is a generic setup which shows how the radiated emission testing is done in a chamber, which is an absorber line chamber, how the harnesses are laid out between diagram shown as 6 and 8, and what's the distances between the antenna, which is typically 1 meter distance, and they are raised about 95 centimeters from the floor, so on and so forth. This is a physical picture from a lab standpoint, where a technician is setting up for radiated emission according to CISPR 25. Another picture where a vehicle is being subjected to the radiated emission testing in an absorber line chamber. And finally, I want to go over the electrostatic discharge. The point I would like to mention here is that as we talked about earlier in the discussion, that automotive environment is very different from a product which will be used in a home or an office or other applications where there is a proper grounding system available, where it will be based on AC voltages, so on and so forth. Considering a product is going to be used in a vehicle, threat levels will be different. More so, the overall impedance seen by the electronic assemblies within the vehicle will be very, very different. So all those things will dictate a different ESD model compared to a commonly referred human body model, which we use on a daily basis in a lab environment for commercial products. So based on the vehicular models, there will be various tests. And if we look from one spec to the other, if we look from one manufacturer to the other, we could see slight deviation here and there. However, if we talk in terms of SAE requirements, and more specifically SAE J1455, they talk more in terms of handling of the product, and the voltage requirements go up to 15 kilovolt. And they talk about in-vehicle testing, which is covered by J113-3, and the requirement there goes as high as 25 plus minus 25 kilovolts. So fairly higher voltages, and keeping in mind the impedances and the grounding scheme are totally different in a vehicle compared to a commercial product testing. Conductive transient, in a way we have already covered. I will just briefly go over conductive transient emissions. The idea there is that using a unique test setup which requires a specific listen with a very high speed switch. In my emphasis will be a very, very high speed switch, and Standard has given the specification, and they talk in terms of slow pulses, and they talk about fast pulses. So considering which phenomena we are trying to capture, we will slightly configure our listen and the switch in a different manner and try to capture slow pulses and the fast pulses and compare with the specific limits to determine whether the transient emission meets the specification or not. Very often we see that a manufacturer would have difficulty meeting these requirements due to the larger capacitances inside and some other reasons. Load dump. I just want to kind of briefly touch that. This is the last topic in my presentation. The reason I wanted to talk about load dump is that this is another test which is very often called by the automotive requirements, and very often we see failures. We see over 85 to 90% of the products we come to the lab, if they are not designed correctly to meet the specific threat, we will see a failure with the load dump test. Load dump test basically simulates when a vehicle generator is running, and all of a sudden, due to an accident or some other reason, the battery terminal gets disconnected, which will push all the energy inductively into the harnesses, which will find their way to the electronic subassemblies within the vehicle. And if they don't have enough protection or mechanism to clamp that energy, it will cause catastrophic failure. And that's what we see in the lab environment very, very often. However, there are easy ways to fix that. The primary focus is to find or provide means at the entry point of the electronic subassemblies to drain the transient energy to the vehicle's main ground, basically. So, folks, at this stage, I will conclude my presentation. We tried to cover some of the SAE requirements. We did a comparison of the SAE requirements with the European and UN Regulation 10. We briefly talked about some of the test methods. We talked about some of the OEM requirements like manufacturers like BM, Chrysler, Ford, GM, and others. And we try to do a quick comparison of their requirements and see how they play in with the SAE requirements. And at the end, we spend a little bit extra time talking about frequently requested test methods, primarily in the context of SAE J1455, which is a very, very frequently requested test method in the lab environment. So I will leave my presentation at this point. I'll go back to Tasha. And if you folks have any questions, please feel free to send them back to Tasha, and I will try to address them as much as I could in the small time we are left with. And if any questions are left unanswered, we will try to reply you back with the email. Thank you very much, and thanks for your time.
That concludes the presentation portion of this webinar. Tomorrow, an archived copy of the webinar will be available on metlabs.com. We will send a follow-up email with a link to this file. Now we will answer questions. If you have a question, please type it in the questions area of your control panel. For questions we can easily address now, we will read the question aloud and then give the answer.
Okay, so I have one question which I received, and that is, do the aftermarket accessories considered as sub-assemblies for SAE J113? In my opinion, if the sub-assembly is meant, if an aftermarket accessory is meant primarily for automotive application and it cannot be used for other applications, then in terms of the standards view, it's considered as a sub-assembly. And all the requirements which are applicable to sub-assembly will be applicable to the aftermarket accessory. However, one more key point to remember between the SAE requirements versus the European requirements, there are slight deviations. And if we talk in terms of the European requirements, then the way the European requirements are dictated, for many aftermarket accessories, they give you an option to take the route of CE mark instead of E mark, depending upon the nature of the aftermarket accessory. Tasha, I didn't receive any other questions, so back to you.
All right, so we'll leave this open for a couple more minutes if there are more questions to come through. All right, if you have any additional unanswered questions, please contact us via phone or email. Tomorrow, we will send a follow-up email that will include a link to the presentation. That concludes our webinar. Thank you for joining us today.
Thank you.